If for whatever reason, who are I know the standard is how can the ACLU meet this CP model on it? The answer is it Paul?
Hi, Paul. How are you? Yeah, Carlos already loaded all the.
That's true. But that's because there's still some degree of psychological. But that's why for someone who believes to be an honest world, that's why it's not. It's not
Eric's looking for you. Said no. Okay, can we find a seat so we can get started, please? We'll do the chair stuff first. The chairs have some things to say first. Oh, okay. Okay, as usual, the first thing is blue sheets. We have one clipboard going around. Please make sure you sign it. Second thing is we need a jabber scribe and a note taker.
We have one note taker.
We have one note taker. Okay, need a jabber scribe.
Okay, so let's start. So as usual, the intellectual property that you must be aware. And the note well. Okay, so the blue sheets are, well, one is circulating. We have note taker and Russ will be in Java. So this is the agenda for today's session. We'll do some administrative stuff at the beginning, and then we will focus into the main two working group documents, the one about IPv6 over .11 OCV, and then the plan statement and use cases document. And then, time allowing, we will have a short presentation on neighbor discovery for IPv6 and another one on TLS using ATS, but this is time permitting. So we have one slide on the liaison. So maybe Russ, you can explain.
Yes, we got a liaison statement from ITU SG16, basically informing us of some work they're doing. They this was posted to the mail list a little while ago. We received it on the 3rd of September. They just want to make us aware of this work, and if we have anything to say about it, they'd love for to hear about it. But basically, they're calling for volunteers to participate in this focus group. If you're interested, you don't need to come through us. Just talk to the ITU directly. Focus groups don't have the same formal membership requirements as some other ITU activities. So if you look at that liaison statement and you're interested, go ahead. Thank you.
Okay, thank you, Raj. So, short working group status update. So we have, as you know, two documents in working group process. The first one is on the transmission of IPv6 over EO2.11 OCV. This document has been stuck for a while due to some 6-man raised issues, concerns. We'll see just after this a presentation from the authors, and then we will discuss how to move forward on this document. And then we have another document that is the problem statement and use cases document that has been through some reviews, but we still need some additional reviews to make this document move to the next stage. We will discuss that later as well. So this is the status. As you can see, we are late on the original deadlines. We are very much aware of that, and we'll see how to actually speed up things during the meeting. So on the next steps, we will, as I mentioned, discuss the review has been done on the OCV document and see whether the 6-man race issues still remain. We believe that there are things that are still to be done, and we are discussing some ways of approaching this or addressing this. Maybe adding some new editor may help, but this is still under discussion. But we believe that this document is not ready yet, and we will need to do some work and then submit to the AG, but not before the 6-man basically agrees with the document, as stated in our charter that the 6-man has to review the document that we produced. This on the first one. On the second one, on the survey problem statement use cases document, we got some reviews since last IETF meeting, and that's very good because we managed to get something that is a good starting point, as actually some of the reviewers mentioned. But we do need additional reviews. I mean, this is a starting point, but we need more mature reviews on this iteration, not only to improve the quality of the document to a level that is good enough for publication, but also to provide some proof that the working group has energy to do additional stuff, because otherwise there is no point of having a problem statement document if there is no problem then to be solved. So we really need at least 2 additional detailed reviews. So it's not about typos, editorial kind of review, but really on the content of the document before IETF 104. And we need a new version of the document before the meeting. And by before the meeting, I don't mean 2 days before the submission deadline, but at least one full iteration before. So basically 2 additional versions before IETF 104. Otherwise, I guess we have been waiting for quite a long time. So we will be maybe forced to drop the document if there is no energy on this. So we will discuss that later as well. And that's basically it from our side. So let's move to the next point in the agenda. Nabil.
Hi, this is Nabil Ben Amar from Morocco. I'm an ISOC returning fellow to IETF. So I'm presenting our draft transmission of IPv6 packets over IEEE 802.11 networks operating in mode outside the context of basic service sets. So since the last IETF meeting that was held in Montreal, the draft is updated with all recent comments since that IETF, including comments from six-man working group, from Eric, and from the Human Rights Protocol consideration that help us to consider all this statement and to include it in the current version of the drafts. So as part of efforts of the Human Rights Protocol consideration, Amelia has reviewed the Human Rights consideration and suggested to remove the reference to .rfc, which is 8280, because it doesn't need to be listed in the reference as it's an IETF research group document, and it's the review is meant to be helpful and in no case mandatory. So the main comment that we have received from six-man are related to, in part, to the neighbor discovery. So the main neighbor discovery change were suggested by six-man and by Mr. Eric Nordmark. They were addressed in version 26 and 30. 30 is the latest version that we have. The respective changes are listed in the change log. So if you want to have more details about all the changes that we have between version 26 and 30, you can just compare the change logs. So they are in 30, in the version 30, a clarification on the reliability of ND over OCB and over 802.11 links. So we added the following paragraph. The neighbor discovery protocol is used over 802.11 OCB links. The reliability of the ND protocol over 802.11 OCB is the reliability of the delivery of ND multicast messages. This reliability is the same as the reliability of delivery of ND multicast messages over 802.11 links operated with BSS ID. So we have added that paragraph, and we are waiting for comment from Eric. So, okay, comment from six-man. So in the for the 26th version, so we moved text. Okay.
So if you go back to the slide, so Eric Nordmark. So the second paragraph is second sentence is actually incorrect, right? Two things is incorrect. One is ND uses both unicast and multicast. Two, ND actually sends multiple messages. So if a single message is lost, you're not dead, right? So the wording here could use some improvements. The thing that's important to keep in mind for OCB is that unicast is as unreliable as multicast, which is different than Wi-Fi, right? What people have done on Wi-Fi is saying that, okay, if you can switch to unicast, we're better off because it's more reliable, we have ACKs. But it might make sense to state that fact that OCB, because it doesn't have ACKs, because it doesn't have associations, unicast is as bad as multicast, or as good, whatever it is, right? But you should actually fix that second sentence, because I think it will actually continue to confuse people.
Okay, thank you, Eric. So you suggest to rewrite the second sentence in this paragraph?
Yeah.
To focus also on unicast?
Yes, and you could actually weave it in. I could suggest some words, but.
Okay, thank you. Thank you for your comments. Back to version 26 of the draft. So we moved the text from Slack section and from design consideration appendix about privacy into a new privacy consideration subsection of the security section, as had been suggested by in the mailing lists. Reformatted the Slack and ID section to stress only link locals that can use UI 64. Removed the GOP Wireshark explanation or reformulated the Slack and LL sections. Continuing on the comment from 6man, we added a brief mention of the need of use of link local, clarified the text about MAC address changes, dropped pseudonym discussion, and changed title of section describing example of packet format. For the privacy protections of vehicles, which has been also comments that we have received from Dirk and Amelia. So we added that paragraph that you can see in the. So we need to add this paragraph in future release of the document. So it's basically about the demand for privacy protection of vehicles and drivers identifies which could be granted by using a pseudonym or alias identity at the same time may hamper the required confidentiality of message and trust between participants. So that's all for this draft. Thank you.
Okay, thank you, Nabil. So I guess you didn't get like a kind of the blessing from 6man, right? I mean, the last revision has not been reviewed by 6man as such. So we need that because I believe that the 6man will not be happy with the current version either. So we need to probably get another review from them to highlight the things that need to be addressed.
Suresh Krishnan. So one more thing is like probably also to check with the IPWAVE working group to see if they're happy with the changes, because I don't see like, like the closing the loop in the working group. So maybe we can probably do like a 1 week last call or something, not this week, but the week after, say like, okay, like, are you happy with the changes that have been made since the last working group last call? Because I think it's pretty significant amount of changes since the last working group last call. So once that's done, probably I'll do the same process for 6man to ship it over. But I think doing this in lockstep is probably not going to work. So we can probably close one off and then go again, do another shot. Because I think it's going to be very difficult to try to do a last call in both the places at the same time, because there might be somebody who might come up, like even like stuff like, Eric was talking about like some fairly obvious things that like shouldn't be controversial seem to be controversial, right? Like some appendix or something, right? So I just don't want to like, correlate these two things at the same time. So like get it closed off here, send it off to 6man, bring up the issues here again and go on. So even if it takes time, I think it makes more sense that way.
Okay. I agree.
Thank you.
Yeah, so, Eric again. So two things. One, I was looking through the 6man comments, and there's at least one that hasn't been addressed, which is the paragraph after the ND paragraph that refers back to that paragraph, say, as the motivation for mobile IP, whatever. And people pointed out, I don't know when this was in the last couple of months, that back reference doesn't make sense given that you now changed the paragraph it's referring to. Right. So that's something that needs to be addressed. I think in general, it works well when there's email responses saying, okay, based on what you said, we've changed this section to this, whether it's 6man's comments, the one I made, I have to go look at the diffs to actually figure out what was actually changed, right? Because the changelog in the document is extremely brief. So I haven't pulled up the diffs yet to see what actually did change, but doing that stuff so that people can actually see that, okay, you did change something in response to this, or at least you responded saying, oh no, you're confused, we don't need to change the document.
Okay, thank you. We'll check.
Yeah, Suresh Krishnan. So that's kind of what I was implying by closing the loop, right? Like, there's like people don't know that you made the change, like, or what change you actually tried to make for a given thing. So like at least for Eric's email, right? like you listed, like, what are the changes you made, but all the 6-man comments, right? There's no closure in 6-man for the comments that came in, right? Saying, okay, this is what we changed in the draft. This is why we're not making a change in the draft, and so on, for the issues that came up there, right?
As far as I know, so we have received many comments from 6-man, and we addressed all the comments because it was
No, it's not about addressing. It's like
in the
closing
mailing
loop.
list with Carpentier and
Lorenzo?
exactly. So we have answered in the mailing list. You
Okay.
can see in the mailing list. So there are some points that we didn't agree. So they were not impacted in the draft, but we didn't get other questions from them or comments from them.
Okay. Okay. So we'll just probably go through it. Like, would it be useful for you, Carlos and Ross, if I set up an issue tracker for this, so you can actually keep track of the issues and close them off and go on? Because I feel it's very weird, like, to get an issue tracker, we have to go through this like side process to get one, but I can get an issue tracker for this, if that you think that'll help.
I'm not sure the list is so long, we need an issue tracker. If we just compile one email that says, this was your issues, this is how we address them, don't you think that's enough?
That's fine, yeah.
Okay.
Okay.
Perfect.
So then, just to summarize, the process will be, I think there are some comments pending for being updated in the draft, right?
Okay.
So you guys submit a new version with all the changes that you think at this point were necessary. You send an email summarizing all the changes you made and where those comments came from, like 6-man did say this is the way we have addressed the comment. If there is a comment you didn't reach an agreement, you say, like, we didn't reach an agreement, so this is still open. You summarize everything. Once we have that, we go for working group last call 1 week in the working group. And after that, whatever comments we get and a new version potentially addressing that, we ask Suresh to go to 6-man again, right?
Perfect.
Okay, thanks.
Thank you very much. Thank you.
Hello, this is Jeon Paul Jung from Sungkyuan University in Korea. The bottom of the slide lists up our co-authors. So this document about the problem statement addressing what is next step for IPWAVE, if we can, and also show the several use cases. After Montreal meeting, we updated the 2 versions. So especially the comment from volunteer reviewers, Eric and Dirk and Fran Sois and Michel and Emilia, okay. So except the Emilia, that review is a human rights review. So what is related to the human rights point of view? So I read her the review, most of focus on the security stuff. So I tried to address especially privacy issue, so I can polish up our problem statement document. But other technical part, I believe, I addressed. Also, we agreed just to focus on 3 key work items. The first one is neighbor discovery. The second one is the mobility management. The third one is security and privacy. So the major changes is neighbor discovery. I would say vehicular neighbor discovery, VND. So last time, the Eric Nordmark, he asked what is definition of a vehicular link model. So this draft, we try to address the link model. So maybe we can discuss. This is very important. The second one is the neighbor discovery based proactive handover to support the transport layer session continuity. So we can take advantage of link layer parameters such as received channel power indicator and also location of RSU and its coverage. So we can predict when the mobile vehicle will move out of the communication range RSU. And the RSU also can determine what is the timing to perform the handover. So we can take advantage of that information. So that is second one. Third one is a vehicular network architecture. Try to clarify vehicular link model. The last one is also RSU network is connected to vehicular cloud. So I will explain one step at a time. This figure shows the vehicular network architecture. So you can see the bottom, we have two subnets, subnet 1, subnet 2. So this figure is very important. So you can see the RSU 1, RSU 2, two RSU are sharing the same prefix. So we try to construct the multi-link subnet, which means one beaker V1 configured by the prefix announced by RSU 1, and then in moving to another RSU wireless virtual link, it doesn't necessarily reconfigure again because the same multi-link subnet. We try to reduce address auto-configuration overhead, right? Because you can see usually RSU will be deployed intersection area. Sometimes highway cases, some intermediate road ways. Most of the cases, the urban area, the vehicular people think intersection is a good position. So you can see the usually intersection distance is less than 100 meters in the United States case. In that case, every RSU visit changing new address is not efficient. So I envision we try to construct the multi-link subnet, and then we can allow just a one-time address configuration will be enough. However, sometimes another RSU3 can have another subnet prefix. So in that case, somehow we needed to perform some handover. So Tri and I discussed so mobility anchor, this structure similar to proxy mobile IP structure, such as LMA. So this one can handle different subnet prefix. I think that is some different from proxy mobile IP structure. So we try to take advantage of the position of RSU and trajectory of a vehicle, because vehicle can equip with GPS navigator. So vehicle can recognize its position, speed, direction. That information periodically reported to RSU. And RSU can share that information with the neighbor RSU. Also, it can report to mobility anchor. So mobility anchor is a kind of controller, govern or mobility management. So I think this is a new link model. Also, important thing is secondly, the vehicular case communication between vehicle to vehicle should V2V rather than V2I and I2V. It takes time. So we support B2B, also B2I simultaneously. This one is, I think, different from traditional infrastructure-based wireless communication. So we need to support both. So this figure shows a V2I communication scenario. You can see this is the left-hand side, the vehicle in-vehicle network, and the right-hand side, RSU, internal network. So nowadays, the industry, they are trying to make internal network using gigabit Ethernet, providing some diagnosis or other some sensing for some adaptive cruise control purposes. Many data can be generated. So we can see this one is a moving router, okay? It is communicated with another router. This is, keep in mind, the RSU. So this interface is used to access cloud, connected to a mobility anchor, to take some internet services or communicate with this vehicle, another vehicle located at another subnet link. Okay, so we needed to consider this kind of internal network as well. Okay. Second one is the beaker to beaker case can communicate with each other. So in this case, we can say one important the application in the driverless autonomous vehicle scenario case, we can learn some cruise controller or context-aware navigator. They can communicate to each other to aware the neighboring vehicles, also neighboring pedestrians to avoid conflict or accident. So in that case, some application learning some host to another cruise control application learning another host within in-vehicle network. They should communicate to each other. So the question is how to provide this kind of communication. So that is different from other existing MANET or other some DMN, other scenario. Okay. So I tried to clarify the link model based on mainly from the Erin Nordmark. So the legacy IPv6 neighbor discovery protocol is not suitable for vehicular wireless link because the major concern is symmetry in connectivity. You can see the vehicular case, depending on transmission power, also interference in air. So one transmission not necessarily guarantee the other transmission, right? So asymmetry in the connectivity exists. And also, lastly, you can see the multi-link subnet case, they should reachable, even though the multi-link subnet consists of a multiple wireless link with the same prefix. So the how to handle. And also the vehicular case, the vehicular add-on network case, even though sometimes within some subnet domain, but maybe they disconnected because of some communication range, right? So in that case, we need to communicate using RSU relay, something like that. So this is very different from traditional the IPv6 neighbor discovery protocol assumptions. So we need to clarify. So as a result, we have some new features for vehicular neighbor discovery. So Eric suggested lightweight DAD using ND optimization from 6LoWPAN. 6LoWPAN, the major concern is energy consumption. So they try to avoid ND broadcast. So if some IoT device requires some address prefix case, just the unicast-based router solicitation message delivered, and the router can receive and then handle using multi-hop DAD. So in the same way, we take advantage of this one. Imagine you can see the one intersection area, 100 over 200 vehicles moving around. They try to reconfigure. So in that case, we need to minimize traffic overhead. That is, I think, important. Also, it moving to another subnet, try DAD again is, you can see, inefficient approach. So that's why we need to consider this one. So single address configuration, multi-link subnet, I think is enough. Also, the handover among RSU and the MA mobility anchor can be used, support, take advantage of trajectory and the position information of the vehicle. Also, we handle dynamic topology BANET. Also, multi-link subnet forwarding, we need to consider B2B or V2I, I2V. So we need to consider that one, depending on the location of vehicles. Okay, and then let's move on MAC address pseudonym for privacy. So in that case, MAC address is periodically changed, affects address change IP layer. So we need to handle. Okay, Charlie, go ahead. Yeah.
Yeah, my name's Charlie Perkins. Can you go to the last slide just for a moment?
Okay.
There's a document that's just about done in 6LoW. It's called RFC 6775 update. And I think it really deserves consideration here because there's a lot of discussion about how to have multi-hop registration for these devices, as well as you might say some improved verification capability, which might come in handy here as well.
Okay, so what is the name
Charlie,
document?
what was the RFC number?
It's not on RFC yet, it's in the RFC editor's queue, but I mean, they're finishing it. But it's RFC 6775-update. It's a 6-low
okay.
document.
Okay, sure. Okay, thank you. Yeah.
Yeah, just to clarify, it's an update to that RFC, so it has some additional pieces associated with it. So, but it's fun. It's the same model, right? It's just adding some pieces.
Okay, good. Yeah, thank you very much. So the MAC address pseudonym case, the important thing is current my idea, the MAC address pseudonym case, the change in IP address affect the TCP, such as the transport layer session, should be maintained, right? So we need to consider of that. So we can take advantage of existing mobility management scheme. Maybe it is not good enough. We needed to adding more. And also, V2B scenario case, prefix dissemination exchange is very important. I explained the previous the slide, V2B scenario. And then mobility management. So efficient mobility management, seamless connectivity and timely data exchange. So we can take advantage of mobility information sharing with the infrastructure load, RSU and mobility anchor and the vehicles. So proactive handover can be used. So as a result, the trajectory-based mobility management can be used. Okay. Nowadays, every user, driver holding a smartphone or vehicle nowadays, that's the system providing navigation system. We can take advantage of that mobility information for mobility management. Also, with that kind of prediction of the vehicle mobility, we can perform efficient DAD, data forwarding, and the handover, proactive manner. That is, I think, very important, unique point. And also, we take advantage of link layer parameter, such as receive the channel power indicator or RSSI over the outer layer frame. We can use it. So next step is, Carlos mentioned that we takes two intensive reviewer, maybe the Gunda Valley, right? Three and other expert, maybe the volunteer, about the mobility and some Eric, the review again, maybe. So we can move out. And then we need to restructure and be moving out to develop some protocol. Okay, thank you.
Okay, thank you, Paul. So for the reviews, so we need 2-3 reviews before next IETF. So you suggested 3. I don't know if you can do it. Okay, so 1, thank you very much. Charlie was also mentioned. Well, I don't know if mentioned. I was thinking in Charlie. Charlie, can you take a look at the current version and provide some comments as well? Okay, thank you. And any other volunteer?
I am Rahul Jadhav from Huawei Technologies. I have a question regarding the mobility scenarios that you mentioned. One of the things that Wave has done is removed some handshakes, and they have updated the authentication scheme at the lower layer, just so that it reduces additional RTTs, that are involved. And now at the above layer, with 6775 updates, we are going to introduce. So what I was wondering is there any information in the draft which gives this information that this is the hard bound that is kept by the Wave standard?
Oh, so what is your question? I cannot.
Okay. So
yeah.
Let me
clarify. So what is your concern is about some security issue?
No, it's not security issue. So the layer 2 Wave has changed their handshake mechanism so as to reduce the number of RTTs that are involved for certain scenarios.
Right.
And now we are adding those RTTs at the above layer. So what I'm trying to understand is there any hard bound that has been placed by the Wave standard on what amount of time can be spent in this this authentication handshake or any other handshake that is involved at the layer 2? I'm just worried that at the higher layer we are introducing those handshake and increasing the time bound,
Okay. I
So,
see. Mm.
Is there any specific considerations that you have done for that particular aspect?
Okay, that's currently, as long as understand the wave case, they are focused on V2B scenario rather than V2I. So because the handover usually involving the IP, right? So communicate with some other corresponding located some other subnet. So, but that exactly IPWave will help working on that. So I think that is no reference yet, as long as I understand.
Okay.
Okay. Yeah. Probably that is a very important issue.
Right. So I read the draft last time. I didn't see such information, but then I tried to check whether such any such hardbound is placed by the wave standards. I didn't find anything specific, but I just wanted to know whether you know of something like this.
Yeah. Okay. Thank you.
Thank you.
Shri Gundavali. So Rahul, you're saying that is more about L2 setup, the time. Okay. So, but here we are not talking about the solution approach yet. I know even Paul is talking about, even though he's talking about the different mobility management approaches, we are not sure if you're going to build a layer 2 domain. In one approach, is RSU a router or a bridge, right? Essentially, in one model, we can have some higher level aggregation gateway, build a large L2 domain, right? Like today, how CapApp does, right? If you keep it very close to CapApp kind of architecture, that's one, we need to look at how that impacts the different mobility management scenarios. But if you look at RSU as more as a L3 router, then what Paul is talking about, like a handoffs and all of that, in that model, we need to see how it impacts. So we haven't discussed any of the solutions. So this is just a high level commentary at this point. This is because it's a problem statement document. These are all potential problems, but I think we need to look at 1609 specs, what exactly is the issue, but yeah.
Okay, thank you, Datri. Yeah, okay, sorry.
Hello, my name is Amelia Andersdotter. I wrote the human rights review that you put to be decided. And so I would just like to have clarified for myself which parts of the review that were difficult to understand or why the concerns weren't incorporated.
So are you the Amelia, right?
Yes.
Okay. So that is very helpful. It's firstly the privacy issue, a PIN number, vehicular identification number issue, other synonym. I think very helpful. I tried to address the summer part, but summer part it is looks like not easy to. Yeah. So we can discuss. Okay, after some.
That would be helpful. Thank you.
Okay. Thank you. Yeah. Okay, Eric,
So,
go ahead. Yeah.
Eric, not mine. This is not necessarily a comment on this draft, but it might sort of fall in between the two drafts. And so I realized going through the various comments that, well, one thing that we haven't specified as far as I know is the base case of the vehicle is talking to one RSU and a second later it's talking to another one because it drove down the road, right? And how does that actually perform today? And what sort of level of tuning is needed? We have these various RA advertisement interval. We have ways of setting router lifetimes and reachable time and other things, right? And I don't know if anybody's done any experiments with that, with sort of current code and see how does this behave if a new RSU shows up every second or whatever, right? I mean, even if you're not trying to get global routing to work, but you just want to be able to ping the default router as you're driving down the road, right? That would be a useful test case to see how quickly can you actually discover that there's a new default router, you shouldn't use the old one because you lost connectivity, right?
Right.
And I don't think it requires protocol changes, but at least we need to figure out what sort of tuning is needed here. So that's a lot simpler than this. Your mobility management here assumes that you will find out about, I'm now talking to a new RSU, I should stop talking to the old one, right? And I can run my mobility protocols on top of that, but you need to find that out in a reasonably timely manner. So has anybody done experiments with this?
So actually, the current situation about the IPWave case, the Ether 11 OCB driver and system is not popularly available. So, for example, my lab purchased Coda Wallet's RCU OB very expensive. So experimentation is so. I think alternatively, my lab are working simulation based, realistic ladder model, fading model, try to figure out what is the limitation of current the existing protocol. So that's why next slide, we try to come up with a new some approach for link model and the neighbor discovery mobility issue. So we are working the simulation. So hopefully next, the prior meeting, I bring my student to try to demonstrate what is the limitation of existing protocol, what is our proposal. So at least the simulation. After that, we can moving out the real implementation. I believe.
Yeah, I mean, we can talk offline about ways possible to run experiments too.
Okay, thank you. Yeah.
Okay, thank you. So any additional volunteer for reviewing the document? As we discussed, we need 2-3 reviews before we even consider going for working group last call. So we got 2, although one is from Charlie, that is, I just realized that is a contributor co-author, but then anyway, that will be helpful. The other one is from Sri, and any other volunteer?
I recommend Jonghyuk Lee. Jonghyuk also, he's an expert. Oh, you're okay.
Okay, so well, take it offline, but you need to really find at least 2 more reviewers. Okay.
Yeah. Okay.
So then we move to next one. That is.
Okay. This one is try to come up with some possible candidate for IP version 6 neighbor discovery for IP-based vehicular network. So the Zhong Shang and Chris Shen are my student. So the introduction, so motivation of a vehicular neighbor discovery is we need some concrete some idea. So I would say this is not necessarily a solution, but it can provide some guideline for our further the moving places. So the subjects handled by this draft is definition of the link model for vehicular wireless links. The secondly, neighbor discovery optimization with multi-hop DAD. And the third one is proactive handover with vehicular neighbor discovery in the mobility management. Last one is MAC address pseudonym handling. So again, this is a picture you understand, right? So we try to provide the B2B and the V2Y consider a multi-link subnet scenario. So again, the beaker is registered through RCU, and this address actually register into mobility anchor. So this link coverage case, its neighbor cache entry having the beaker's address information. Also, that address information is delivered to a mobility anchor. So as a result, another beaker tried to register using this RCU2, and RCU2 try to register address here. If address conflict happens, which means the DAD failed, okay? It is called the multi-hop DAD, and then notify, and then it tries to notify, configure again, otherwise register. So in this mechanism, we can provide the one-shot DAD is enough, okay? And then it can moving out. So mobility point of view, we can using the proxy mobile IP, it can handle, okay? Okay, 3.
Yeah, so Paul, when you say register, is it like a proxy? What exactly is RS? What is the function?
RSU kind of proxy. So let me show you this one. This one. So the beaker sending try to send NS with the address registration, and then RSU received. So first of all, it has a neighbor cache. It can cache its address, and then using duplicate address registration, this one has the DAD table, the register. Take a look at its DAD table. If it is a conflict case, this duplicate address confirmation saying there is a conflict. Otherwise, okay, it is okay. And then it can acknowledge, okay, the assignment, and then that is enough, okay.
So again, going back to my earlier comment, if you look at RSC as an access point, right? And essentially mobility anchor is like, somewhat an aggregation gateway, like a wireless and controller, right? If you look at CAP5 architecture. Now, do you still need this kind of, so if now in that L2 model, right?
Mm.
How is it impacting this call flow here? In other words, keep everything, all the state on the mobility anchor. Make RSU more as L2 pipe, right? Between RSU and mobility anchor, it's just a layer 2 pipe. Now, how does this impact your scenario here?
So your point is the mobility anchor is a kind of the bottleneck point. Try to using the DMN approach.
No, forget about DM and all of that. All I'm saying is RSU is just a L2.
Oh,
node.
so currently, RSU. My assumption is RSU is L3 as well. Some depending on some. This is some just a switch case, probably some router behind the RSU. But my definition is RSU is the router.
Yeah. See, if you deploy RSU every 300 meters, right? Now, if I'm going at 90 kilometers per hour, I think this model may not work. I think we need to really think whether RSU is an IP node or a L2 node, and I think we need to look at the scenario. Maybe building a large L2 domain is one approach. I think, but we need more discussion. Yeah,
Okay.
I'm not quite understanding how it is solving the problem here, but with respect to all the scenarios, but we need to look at.
Yeah. Okay. So go ahead, Suresh.
Yeah, Suresh Krishnan. So first to make sure everybody understands, this is like a future proposed work item for this working group, right? So we really want our deliverables done before anything like this happens. And the second thing that I found confusing, I don't know if other people did, is the relationship between this draft and draft Jiang, right? And they're kind of interrelated, but it's not very clear how they're interrelated. So I would really recommend that you try to put them together. So because I don't really understand why they're separate.
Okay. So actually, the Zheng is my draft and Shang is my student. We in the future try to merge. At the moment, we take refer to some options, but in the revision case, we can merge. Okay?
Right. So that's the thing, because this one uses option definitions from the other draft, and I had to go back and read it to make sure I understand.
Right. Yeah.
So I think it causes some confusion. So take care of that. But I would really not discuss the details. Just give up. We don't have too much time, right? So just use the time to provide an elevator pitch, 2 minutes of the thing, and then.
Okay, sure. Okay, good. Yeah. So I think that is the main idea, and that we can handle pseudonym and the mobility. Take advantage of RSU. I explained the problem statement document. So next step is once we finish problem statement, we need to start neighbor discovery for B2B, B2I. That is my intention, this document. So to proof of concept, currently we are implementing right now, we finished up the basic neighbor discovery protocol implementation. Next step, we implement our proposal. So next hackathon project, we try to come up with. So as one information, I also leading some I2NS hackathon. We 7 times hackathon. I2NS working very energetic. You can take a look the working group, a lot of working draft. So more than 60-70% our groups. So I want to bring in energy into this working group using real working code. Thank you for your comment. Okay.
Okay. One question or comment regarding this hackathon project. We are also aware that I think, Nabil, you have some implementation work going on, right? On the basic IPv6 over OCB with some students. That's correct or not? So my question is, if you have also some implementation on the basic IPv6 over OCB stuff, because if that is the case, I think it will be very valuable if you go for this kind of hackathon where you do some interop tests on the basic draft. That will be very helpful for that draft to progress, to understand what are the issues. And then that will be also very helpful in understanding what are the potential things that need to be improved in a potential future work. As Suresh mentioned, nothing will happen until we are really done with the main 2 documents. So I think we should focus on those 2 main documents, so basically on the implementation of the OCB basic stuff. And that will be very, very helpful if you can do a hackathon kind of interop in the IETF. And if that's the case, we should prepare and advertise so maybe some other implementations or some other people can join. Okay. But I will mainly make the hackathon around the IPv6 over OCB main stuff. Okay.
This is Nabil again. Thank you for this suggestion. We have indeed in the last AES, African Internet Summit, we have done a hackathon, and there were 3 tracks. One of them, it was around IPWAVE. So we brought some network cards related to OCB, and it was successful because we have been able to implement those cards in Linux, turn the Linux, recompile the kernel, etc., and make the ping between two nodes that they are virtual vehicles because of those cards. And we got some good results. Yes.
So yeah, I would like to collaborate with the Nabil's team and the lab, and we can take leverage, right? And then we can move out. OCB first, maybe the neighbor discovery option. Okay.
Okay.
Thank you.
Okay. Thank you. Yeah.
Thank you. So let's move to the last one.
Hi, I'm Munira from Telecom Paris Tech. I'm presenting you today the extension of Transport Layer Secure Protocol to support the vehicular certificate, HC and IEEE certificate. So the agenda of this presentation, I will start by describing our motivation, use cases of the extension, and the extension, how it works on TLS. So cooperative intelligent transport system are very highly mobile system with limited bandwidth. That's why we are not using known certificate and known security tools. That's why we are using size optimized certificate standardized by HC and IEEE. HC is 103-097 and IEEE 16092. The HC1 is just a profile of the IEEE one, so it has the same data structure. Our objective is to make this authentication and to define the authentication method more optimized for bandwidth and processing time to support delay-sensitive application, and to enable client and server authentication in CETS network. Some use cases for this extension is the upload of vehicle data and vehicle, let's say, log server to log, for example, to upload it from vehicle to log server, and to update vehicle software and vehicle configuration also. We can use it also to make connection to cloud services, connected infotainment, and also to connect a client vehicle to a company using TLS servers like rent company and car manufacturers, and also wireless electric vehicle charging. The extension, how we make it really in TLS, it's just adding a new certificate type to existing types X509, raw public key, and the third one, it will be 1609.2. And to define its entry structure on TLS. And here I'm describing an example of handshaking, where the client is proposing to use X1609.2 and the server, and he gives to the server the possibility to use one of this authentication method. The first one, X509, the second one is raw public key, and the third one is 1609.2. And so the client will keep his certificate 1609.2 for authentication, and the server will choose the default one, which is
X509. It's a hybrid utilization of such certificate with X509.
Can I ask you one basic question? So in .2, 1609.2, by default, there how many certificates are there? So there's one from the OEM, right? Or is it the OEM certificate or which certificate? Can you provide some clarity on that?
It has the same, it has SNN data structure, and inside it you can define which profile you want to use. And ETSI is one profile on IEEE.
So it's IEEE profile.
Yes,
right?
let's say the general data structure is proposed by IEEE and ETSI, and you can profile just you can define a profile under this general structure.
So within that profile, if it's IEEE profile, is that like a manufacturer certificate or some other?
I mean, so it's a profile. So it's we verify the certificate in the same way, and we serve. It's the same fields. Just for example, on ETSI, some fields are optional, are deactivated by default, and on IEEE is more general, let's say, definition. But on the verification, we have to follow the algorithm, the verification algorithm of IEEE, even for ETSI certificate.
Okay.
Yeah.
It's on the profile. Thanks.
Yeah. So here we define a new value referring to the IEEE certificate to add it to the certificate type, the client certificate type, and server certificate type as defined on latest TLS RFC. Thank you.
Okay, thank you very much. So with this, we are done for the day. Thank you very much. Where are the blue sheets, by the way? Thank you.
Thank you.